All right, welcome back to Chapter 6, video number 7. In this video, we're going to have a look at how to pass arguments by reference, how to pass them by value, and how it works in the memory of the computer. So when we're passing, and we talked about this by passing a value, an argument into a parameter here. And there's another option here that we can add to this called passing it by reference. And when we pass by reference, it allows us to do slightly different method on how we handle the argument as it gets passed into the method. So if we do want to do that, we want to pass by reference. We use this ref when we're passing it into a method. When we actually activate the method, we also have to use ref if we want to pass by reference. Now, if we don't put it in, it's considered passing it by value. So we've got this passing by value, and we've got passing by reference. And really, what are the key differences? Well, to really understand it, I think what we need to do is have a look at how this gets handled in the memory of the computer. So what I'm going to do here is I'm just going to open up my slideshow, and I'll go through this. So describing, let's see here, I'm going to do this one. Describe the difference between a value and a reference. So a value and a reference data types are managed differently in the RAM of the computer. So we've seen things like this where we've initialized a variable like a and we've assigned it to an actual integer value like 10. They refer to that as referencing by value, because we actually just put in a value here into that variable in the memory. Now, we've also done things like declared a string, and we've initialized it, let's say here, to Bob. Now, that's what they refer to as by reference. So now we've got the two different value and reference. So what's the real difference? Now, I'll give you a couple of other examples. We could also do an integer, but an array, which we haven't talked about yet in this course, and we could initialize 3 separate areas, 0, 1, 2, and we could initialize the values, and that's also by reference. Another one would be a Boolean data type, which we could use like a flag, like catch it, and it's either true or false, and that would be a value type. So these are some examples of values and reference types in memory. So we know when we declare a variable, it's put into the memory. We kind of map it out. So what I'm illustrating here is the RAM. You could think of the RAM in two major areas. One's called the stack and one's called the heap. So the stack has to be addressed. So we need to know where everything is, and they use this hexadecimal naming system. And this isn't accurate. This isn't exact, but it's kind of the idea. So we've got this number here, and it increments by 4 bytes, for example, and so on. Over up on the heap, a different part of the memory, we've got some other kind of similar type of addressing convention there. So what we're going to do when we declare an integer data type called A, and we're assigning 10 inside of the stack, we've actually declared out a certain amount of memory, let's say 4 bytes, call it A, and we actually put in the value inside the stack. Where when we do something like a string and we give it the variable name, we're typing in Bob, but Bob it's a reference type, so it gets put up on what they call the heap, and we're referencing its address of where Bob can be located. So we're not actually looking at Bob, we're looking at its reference to where Bob is out on the heap. So there's the value, 10, and there's the reference of where Bob can be found in a different part of memory. And this has its advantages when we're coding. So let's do another one of these. So there we go. The values are stored directly inside the stack, where the references are actually just references to different locations in the heap memory. So if we were going to do this, an array, it's a similar kind of idea where we're actually creating an array and it's a reference. So it's this particular address is what we're referencing if we need to know exactly what we're going to place into a particular in this case, it's an array, and we could do that many, many times here. So value types are stored in the stack right here, and reference types are stored using the name of the location, the address of where it can be found up on the heap. So the scope changes the stack and is reordered dynamically, where the heap, things just get piled up, just heaped up. The stack is organized, stacked very neatly, where the heap is just piled up kind of in a random order.